Early attempts at the classification of elements. At the end of this session, you will able to understand earliest attempts to classification of elements, importance of Johann Wolfgang Barinas, Barinas triads and logic behind these triads, limitations of Barinas triads, Newland's law of octaves, achievements of Newland's law of octaves, drawbacks of Newland's law of octaves. Now let us discuss few points on earliest attempts to classification of the elements. Many scientists made several attempts to classify elements based on their properties and obtain an orderly arrangement of elements. All the elements having similar properties were kept in one group called family. The earliest attempts to classify these elements and resulted in groups as metals and non-metals. Now let us start with the importance of Johann Wolfgang Barinas attempt. In the year 1817, Johann Wolfgang Barinas, a German chemist, tried to arrange all the elements into groups based on their similar properties. Barinas made his first observation on platinum as a catalyst and discovered elements which led to the development of the periodic table of elements. He arranged the elements with similar properties into groups. He found few groups with 3 elements each. So he called them as triads. Barinas' law of triads. Barinas showed that when the 3 elements in a triad were written in the order of increasing atomic masses, the atomic mass of the middle element is roughly the average of the atomic masses of the other 2 elements in the triad. Example for Barinas' law of triads: lithium, sodium, potassium with atomic masses 6.9, 23.0, 39.0 respectively. The average of potassium and lithium is almost equal to sodium. Similarly, in Group B and Group C elements, the average of first and third element is almost equal to the middle element. Here we should observe that even the atomic masses are arranged in increasing order, but not satisfies Barinas' triads law. These elements are arranged downwards in order of increasing atomic masses. Here, Group A will not form Barinas triads and Groups B and C form Barinas triads. The atomic mass of the middle element is not equal to the arithmetic mean, that is, average, of the other 2 elements of the triad. So, Group A triad does not follow Barinas triad rule. Barinas could identify only 3 triads from the elements at that time, hence, this system of classification into triads was not found to be useful for further classification of elements. Now let's discuss with an example, to understand about the logic behind Barinas triads, and how to calculate average of the elements in the triad. We will take an example of alkali metal group. What is the average of the atomic masses of lithium and potassium? How does this compare with the atomic mass of sodium? Atomic masses of the first element lithium and the third element potassium are, lithium equals 6.9, potassium equals 39.0. Average equals, 6.9 plus 39, is divided by 2 equals 22.95 units, almost equal to atomic mass of the second element sodium, that is, Na equals 23 units. Now let us move to limitations of Barinas triads. A large number of elements could not be grouped into triads. For example, iron, manganese, nickel, cobalt, zinc and copper are similar elements, but cannot be placed in the triads. It was also observed that dissimilar elements were being grouped into triads. Barinas could identify only 3 triads from the elements known at that time. So, all the elements could not be arranged in triads. Barinas' idea of classification of elements into triads was not much successful, as he could arrange only a few elements in this manner.